Alright, this is 7.4, Properties of Logarithms. I'm going to show you how to use some properties of logarithms, simplify logarithmic expressions, and we're going to translate between logarithms in any base. And we're going to see, I'll show you how to do that one, and then I'll show you, you have to remind me in class to show you how to do it with the calculator, because the Inspire can do it super easy. Alright, so let's look at this. The first one I want to look at is the product property of logarithms. The product property basically will state that if you are multiplying two different numbers in a certain base, log of base b m times n, same as log of base b m plus log of base b n. Now keep in mind that those ideas are interchangeable back and forth. For example, log base 4 of 2 plus log base 4 of 32. If you were to type those in the calculator, or if you were trying to do it with mental math, there is no nice even log base, there is no exponent of 4 that would give you an automatically 2 or 32. So the idea there is then, well, let's multiply them. Well, 2 times 32 is 64. So log base 4 of 64 is the same thing as log base 2 plus log base 4 of 2 plus log base 4 of 32. And that one we do have. The 64 is 4 to the third power, so log base 4 of 64 is equal to 3. So very simple, you can do something like that. Here's another one, log base 3 of 27 and log base 3 of 1/9. Maybe you see that pretty easily, that log base 3 of 27 should be a 3. And 1/9 should be a -2, and 3 minus 2 is 1. But if you didn't, you could just multiply, and 27 times 1/9 is just 3. So log base 3 of 3 is also just 1. So you kind of see how those ideas get built. They're saying basically, as long as the bases are the same, you can multiply the two numbers there, and that would give you the new log that you're looking at. Quotient property, same thing. If we can multiply, we add. Then if we divide, we can subtract. That would be the quotient property. And again, these are interchangeable ideas. So the idea here again is that we can show that if we were dividing something, or if we're subtracting, maybe we want to do it that way. Instead of saying log 32, which is 5, minus log 2 of 4, which is 2, 5 minus 2 is 3, I can say 32 divided by 4 is 8, and log base 2 of 8 is 3. So you can kind of see here, sometimes those can be done where they can be made a little bit easier. These properties become more important later as we're doing these with algebraic expressions, so kind of keep that in mind. Right now you're seeing some simple examples that would suggest that, well, why do I need those? Because I can just pop it in the calculator. Again, keep in mind, we'll be doing some of this with equations later. Okay, the power property. This one is probably one of the bigger ones. That one states that if you have log base b of some number raised to another power, that exponent can go in front of the log to multiply the answer. So, for example, log base 3 of 81 squared, I can move the 2 to the front and say that's 2 times log base 3 of 81. Log base 3 of 81 is 4, and then I can do 4 times 2, which is 8, and there's my final answer. Okay, so that's a log, by the way, not BG. Log 5 of 1/5 raised to the third power. I can rewrite that as 3 times log 5 of 1/5. 1/5 would have been, log 5 of 1/5 would have been -1, and -1 times 3 is -3. So that one is a really good one, really big one, especially later on when we get to solving equations, logarithmic equations. Okay, the inverse property, this is also another big one. This is what allows us to actually solve like exponential and logarithmic functions or equations. The idea on this one is this, that we know that logs and exponents are kind of opposites of each other. So if I have something like log base b raised to the b of x power, it would equal just x. Or b raised to the log of base b x of x would just be x. And you can see a couple of examples there. You'll kind of see the importance of that, but notice like I have log base 10 of 10 raised to the 7th power. The log 10 and the 10s kind of cancel each other out, leaving me just 7. 10 log 2, notice there's no base there, so I'm saying that's base 10 because we presume when we don't see a base it's base 10. So those cancel each other out, just leaving you the 2. Some more examples of that. Log base 8 of 8 raised to the 3x plus 1 power. The log 8 and the 8 would cancel each other out, leaving you just 3x plus 1. Or 2 log base 2 of 27. The 2 and the log 2 would cancel each other out, leaving you just 27. Okay, the last thing I want to go over is the change of base formula. I'm going to show you this, and I'll tell you the properties, but I also remind me to show you this on the calculator in class. If we want to change the reason why this was created was because we had, like, say, log tables, or for us to do this by hand, a lot of times we needed to convert it to log base 10. So this formula was like if I was asking something like log base 4 of 8, I couldn't find that on my own. So what I would do is I would change it to base 10. And to do that, it would have been log base 10 of 8 log base 10 of 4. So notice like the base and the answer became like numerator and denominator of a fraction with a log of the base you want to change it to. So when you did that, and again, this was something that we used to have to do because we would do this by hand, we would be able to pull up that off a log table and get 0.093 for log 8 and 0.06 or 0.602 for log 4. Divide those two and you get 1.5. Nowadays with the TI Inspire, this is not as necessary because you can actually type this in as that with the Inspire. And even with some of the older calculators, you couldn't really do this like this. I think with the new 84s, the 84 pluses, you can, but the Inspires make it super easy. Because every time you ask for a log on the Inspire, it's going to ask you for the base and for like that answer value to help you figure out the exponent value. So keep in mind, please remind me to remind you about the Inspire to show you how to do that on the Inspire. Otherwise, that is it for 7.4, and I will hopefully see y'all's notes later.